Okay. Hey, everyone. Thank you for joining me for the 76th meetup. This is San Diego Cppquiz meetup, Tuesday, 5 p.m. Pacific time. Um, let's start. So if you're new, thank you for joining me. Hopefully after 1 hour, you learn new things. That's the goal of this meetup, just to meet and just discuss C++, past, present, and future. So we'll have some future stuff today. If you do want to speak anything that you would like, anything that comes to your mind, please feel free to approach me. We have a Discord channel, Meetup, LinkedIn, emails, anything works. So please feel free to let me know, and I'll be more than happy to accommodate you. I'm always looking for speakers. We are 1,845 members. Thank you for being with us. Thank you, JetBrain, for sponsoring the meetup. JetBrain is paying our meetup fees, which are not cheap. And just thank you for doing that. JetBrain has a suite of IDEs. I'm a big fan of their IDEs suite. I'm using mostly CLion, but also Python for Python. And definitely something that I would recommend everyone to take a look at. CLion specifically is free. Like I'm not sure about the other IDEs, but CLion is free for non-commercial use. That's relatively new. It used to cost money no matter what, but now it's free. And JetBrains also have AI assistant and agentic AI and supporting a lot of models. So feel free to check it out. This is really battery included, all battery included IDE, which I'm highly encourage you to try it out. I still have books, like physical books from the one that Dorothy published a couple of years ago. If you are in the San Diego area, please feel free to stop by my house and pick up. I have like 4 or 5 of them. If you are in Denver, I'm sorry you cannot pick up any books. It's too far reach. So we have a Discord channel. Feel free to join. This is the invite link. If you miss it, no worries. You can contact me via either LinkedIn or the meetup the meetup platform. So I'll give you the and this link is refreshing every so often, right? So this is the agenda. I don't think we'll end up having all of these because I think I prepared more than I can present in 1 hour. I have a hard stop at 6 p.m. So we'll see how it goes. So we have kind of a packed agenda for us. So we'll talk about iterations, iterating problems, compile time reflection, enum and JSON libraries, struct padding, lots of interesting stuff, fun stuff. Packet publication has discount codes for few books, 3 of them. Contact me on Discord if you want. I actually, this is very new. They just contacted me this morning, like my morning, and I prepared this slide very quickly. I don't know if it's ebooks or actually printed books. It might be printed. I don't know. So contact me if you want any of these books, and I'll connect you to packet publication. I have few POCs that I'm discussing with. So so let me know. Okay. shout out. Second. Let me present you this specific new website, Cppquiz Doctor. This person I'm following, basically subscribed, and they have all kinds of C++ material to kind of browse, and they have a recent Lambda, I think, book that they like small book that they published. So check it out. I think they kind of related to Juice, the library Juice GUI development, and just feel free to kind of check this website. Okay, let's do one quiz because I have a kind of a packed agenda. So let's do that. Okay, so give me a sec. Let me share something else. Okay. Unfortunately, difficulty is number like 3 out of 3. So this is Cppquiz 23. Take a look at this small snippet of code and tell me what do you think would happen. Can be 4 options. Let's give you a 30 seconds and take a look on what do you think would happen. It's actually hard, by the way. This is hard. This is a hard question. What do you think would happen? It's okay to get it wrong. This is actually hard. You need to be aware of a specific clause in the standard to get it right. So it's hard. So there is a if const expr, if t the same, so return 0 either or returns to string, and we instantiating it with int. Now the return value is int, but there is one branch of the if const expr. Someone says 0, okay, that's one option. Okay, let's give it a try. Return 0. Okay, so the program is guaranteed to output 0 because it returns 0. Okay, let's take a look. No, it's not 0. So there are 2 branches. They return different types. Yeah, it is hard, by the way. It is hard. Okay, so it's undefined. At least as far as I remember when I prepared the slides. Okay, it's undefined. And from what I remember, we can read it again because I prepared the slides maybe 3 weeks ago. This part, which it's not related to the template parameter, is returned to string, but the function returns int. That's what I remember when I was reading that. It's discarded, so is it okay? It's not okay. It's ill-formed. So this is a UB. It does not, yeah, so string this path does not depend on the template parameter, and its instantiation would be ill-formed, so the program is ill-formed. So you cannot do that. You cannot convert string to int. By the way, MSVC prints 0. So whoever says 0 is correct with MSVC, but it is at time GCC and client gives compilation error, which is good, but MSVC returns 0. So MSVC might be broken. Okay. Okay, let's continue. It is a hard one, by the way. I don't think I got it right when I was preparing that. That was long time ago, by the way. Because this quiz, I think I prepared that maybe months back. Okay. So another shout out to a very nice. So my life, besides my main working hours, the rest of my time, I'm gathering information about C++, what the community is, what happens in the community of C++, and I'm also keeping my eyes open on any blog post or anything that might be interesting for me and for the group. So this is one of the things that I found last month, and it's a blog post with a very comprehensive information about iterators. And I just wanted to put that here, and I have few examples, just a couple snippets of code, but there's like a lot of other information that I just go there and just browse the post. It's actually, it's few pages. This is a github.io documentation, but so this is kind of this is like the beginning, like when it start explaining about iterators. And if you read everything there, you'll be very familiar with iterators, like in any form or shape. So really highly encourage you to do that. So this is an example of output stream iterator that takes stud cout and a delimiter and iterating. So there's actually a few snippet of code of iterating without output stream iterator, and shows how to do it with probably ways that you maybe haven't thought about or haven't looked at in regular code. This is a user-defined iterator, something that you might be doing from time to time. Hopefully you're using AI assistant to do that for you today, which is basically kind of a boilerplate code. This is like an example where the value goes to a specific iterator. Think about cout to like a stream of characters that goes to cout, for example. So this is kind of an example of that. So larger fonts, please. Okay, is it? Oh, you're talking about the actual code. Okay, I'm using a web-based software that to do that. So I'll try to see if there is a way, but there's probably a way to do, like, I'm just using the default font. So, but I'll make sure that next time it's bigger. It's hard to kind of condense a lot of information when it's bigger, but I'll try to see if it makes sense. Okay, so this blog post that I highly recommend you to take a look at is talking about a lot of stuff: type trace, spina, substitute failure is not an error, iterator tags, smart pointers, CRTP, curious recurring template, and pattern, and there's a lot of things. So I really enjoyed reading that. This is something that you need to kind of put in your bookmarks and get back to it when you need to deal with all kinds of iteration related work. So highly recommend that. Okay, so let's talk about June. So June, there was the draft of C++ 26. Everyone we're talking about it. And one of the things that people were discussing was the C++ 26 compile time reflection. Daniel has a blog post that you can subscribe to, and this is very famous. I think he's the author of the Cindy JSON. And since everyone we're talking about it, there's few blog posts that were published during June. This is one of them, and I thought this is interesting to kind of discuss. It is kind of future, like I'm using C++ 20 in my work, not even 23, and 26 is probably, by the time, like 26 probably would take me maybe a few years to actually use it at work. Like usually at work we're kind of lagging behind. Most of us, not all, obviously. It really depends. We had Bryce discussing the future of C++, more than 2 years ago. So May 16, I managed to go back to the YouTube channel that we have, and Bryce was discussing a few topics. Compile time reflection was one of them, and it's very interesting. He discussed a lot of things. That was one of them. So lots of examples in his talk. So if you want to go and watch that, he actually had the same talk in multiple meetup groups. So we were one of them back in 2023. So well, if you're not familiar with reflection, the simple explanation is the ability of the program to examine, introspect, and modify its own structure at runtime. We don't have runtime reflection, we have compile time reflection, but it's super powerful, and people. So RTTI, it's a good question. So RTTI is one. So I think I have a slide on RTTI that mentioned RTTI as like one of the things that we had before the compile time. But yeah, this is true. This is a good point. People that speak about reflection, about the impact, saying that kind of, if I need to echo what they say, is that they talk about it as a whole new language inside C++. And I'm going to show you from the blog post from Daniel, it looks very, very non-C++-ish. So you would need to kind of learn a new syntax. It's basically, think about when Lambda was introduced, it looks very, very strange, right? But we got used to it. Maybe some of us not got used to it yet, but we got used to it, most of us. This is going to be the same. And how much is going to be common for us to see code that is not only libraries, but just main application code, I don't know yet, but it's still something that worth understanding, and because you might see that soon. Okay, so Python, just to show you, I like Python, one of my favorite languages. So Python has very robust reflection capabilities. This is a simple one where you can say, I have this string, there's my variable, and I can check, or I can basically retrieve values of everything's a dictionary. Yeah. Yeah, Python is great. Python is actually a very hard language if you do it correctly, because it's so rich. It's just so many things that you can do if you just not use the simplest stuff. So it's a very interesting language. So so Python has that, like right there. It's easy, and I think it's easy to read. Like my variable is a string, but I can, with reflection, I can actually retrieve the value. I can do the same with a method and call it. So it's pretty convenient. I'm not using that level of Python in my day job, but some people would do. So I tried to kind of list what problems here, reflection can solve for us before we start looking at code. So you'll see it probably in the following domains, like serialization and deserialization. So we'll see one example, object relation mapping, database, and similar. Framework like Spring, Java, ASP, .NET, all of that. Using it for dependency injection and routing. So maybe we'll see that as well. I don't know. It's pretty new for that. Creation of powerful testing, debugging tools. Basically, I think it would solve a lot of boilerplate code that we probably using macros instead of reflection to do that. one of the things, and we'll see another topic later. One of the things you can think about is enum, where you like how many times you needed enum to string to enum, all this stuff. So you needed to have this special library that does all kinds of crazy stuff with macros. So that would go away. It would be easier with reflection. Okay, so compile time reflection. Let's take a look at the actual example. Oh, that's where I think someone says RTTI. So today we have limited runtime reflection. This is type ID. Doesn't provide a lot of information. Some information you can query about. You can query some stuff from some information. But that's it. The idea is to solve more boilerplate code and offer more solutions than just type ID and RTTI. By inspecting the members of a class, this is all compile time. Okay, let's take a look. So let's say I want to generate SQL columns. This is from the blog post, by the way. You want to generate SQL columns, and then you want to generate records. So let's talk about the columns first. So you have user struct, which has ID, name, balance, and maybe something in secret, which is ignored. What I want to create is ID, name, balance. So from this user, I want to create this string. So in C++26, this is how the code would look like. So some of it's pretty easy. You basically have stud string as the return value. And you're going to return the columns, which is the ID, name, and balance. And I want to use the name of the members, right? So this is the part that is not super easy to do with C++23 or before. So some context access and similar, which you can ignore, but take a look at how things look like. So this looks like a lambda, right? Kind of a template lambda. And this is the expand part, which you probably haven't seen yet, and this double carets, which is one of the things that it's kind of a new operator. And if you don't need to remember anything, you just need to understand that we are basically getting the member type. This is just the first, whether we want to have comma or not. And we have the identifier of member, and which is basically the name. And we just append that to the string. So it's gonna be introspect of T, which is the user, and we start having one member at a time. And just creating this string. That's basically what would happen. It looks like, beside the part where this is this expand of non-static data members of P with specific context for each member, this auto member, we just want to take the type and basically just preparing the name, which is basically the string. That's basically what we have. And now, once we have that, we want to create the values. So we want to create this. So it's going to be a string of the values that we want to inject to whatever SQL. Same deal. We're going to return a string. So the values, return the values. Context is the same one. This is the same one. Again, sorry if the fonts are too small.
Keep it. Ulta, not like the ulta.
Sorry, is it a question? Sorry. Okay, so here, instead of getting the name, so we take the member and we're creating a name out of that, we actually want the value. So So this is the object that value. This is where we have the value. If it's a string, so there is some tweaks to show you more options. If it's a string, if the member type is string, now we're using the member type. I think we didn't use the member type here, but we're using it here. If the member type is, if const export, this is all compile time, is a string, then we escape the quotes, fine. Otherwise, we take the value to string and we append that. This is all compile time. I don't want to say it looks like a meta class or meta whatever, but it definitely, if you think about the opportunities that you can have by querying the structure of your program and doing something with that, creating this compile time reflection. Obviously, when the values are populated in a specific struct and you start passing this struct to some function, there is runtime code that actually is working to extract that. But this is like the template of extracting the values using reflection, which I think it's amazing. And this is actually my first time I'm actually looking closely into examples. A few of them, because of CPLUS 26 draft, there are a few blog posts about reflection, so that was one of them. So this looks promising in terms of what it can do. It's compile time, type safe. It's less boilerplate code because you can do much less now compared to what you needed to do with before. So, and generic programming, and I think it's going to be like what people would do with that is going to be very interesting. So this is something that I'm looking for to get my hands dirty, but it is 26. I'm not even touching 23 in my day job. So so we'll see. Hopefully you all got very interested in that and happy to see that. There is a compiler explorer. Okay, you know what? Let's see that. It's actually interesting. The resulting code easier to read. So I remember 2 years ago when Bryce showed his slides with all this. It was very heavy. I think he had like 4 topics. One of them was reflection. I remember it was overwhelming because it takes time to digest what it takes time to digest this whole syntax. I think when we introduced Lambda, like when the language introduced Lambda, it was the same. So this is a simplified way to see how it looks like. So this is a struct of m and n. So I'm getting this context and template. This is interesting. Template for. So I'm actually iterating over the members and just printing the member name as a string, which is pretty cool. Like if you think about it, this is and whether so this is the operator. This double caret. This is the operator. This is on Clang reflection latest. By the way, I tried. I don't remember if it was this. Probably not this one. I think from the blog post I took and tried to run it with optimization on. It took forever. So so it's all experimental. So it might. You probably want to ask, is this going to increase compile time? And the answer might be yes. It might. Probably would. Anything the compiler is doing more probably would. But if you think about the syntax, it's a new syntax. Like this is new syntax. Template for const x per m, and I'm iterating over the members of S, the non-static data members of S with a context, and this identifier of, and this is all experimental meta. So there is header, stud meta is the namespace. So we'll see how it goes. So I think the language would be different, very different, when people start picking it up and iterating. But you'll see it in few years. I think it would take time. Just trying to think like C++ 23. How much deducing this do you see in your code? You know what? Forget about deducing C. Like how many of you using concept, heavily using concept? I don't think the majority here on the call would use concept. I'm using it, but sometimes. So I'm using it because I have C++ 20, but I'm using CUDA compiler that is 17. So sometimes I need to be careful that if my NVCC compiler is including something that has concept, that this is C++ 17 compiler, so I need to be careful. So I can't use it everywhere. So that's something you should be aware of. So I think it would take time for you to see it in the wild, but I might be wrong. Maybe it's going to be faster. Oh yeah. So Andreas has it says August here, but this is kind of something that he would publish in August, and I think there is a way to access that right now. Yeah, I emailed Andreas Fertig. Yeah, Andreas Fertig used to be here in like presenting a couple times at least. So there is another blog post, C++ 26 reflection and compile time. Another relatively short blog post that I recommend you to take a look at. And yeah, I told you my video feed would die from time to time. I don't know what happened. Okay, so this is not really reflection, but it's something that I found by Jacob. You can subscribe. I don't know if you need to be member of Medium or not, but Jacob is posting on Medium from time to time, and this is something that caught my eyes. I thought this is really nice to share with the team because I'm using nlhomann JSON like a lot of people here because it's one of the most common JSON parser library out there, more than C++. I think it's 17 if I'm not mistaken, might be 14, but either 14 or 17. And this was something that I wasn't aware of, to serializing data. Okay, so let's take a look. So let's say you're working with JSON, you need to represent different but related types. So you think about polymorphic but maybe stud variant. So think about vehicle, that could be car or a bicycle, and you need to deserialize a JSON from that can be either car or bicycle. So think about JSON that has different types of records, and it's either polymorphic or can be stud variant. How do you deserialize JSON object to the correct C++ type? And Jacob brings up a nice tip that I wasn't aware of. Maybe other people here on the call are familiar. And let's take a look how he solves this problem. And I think I also had a compiler explorer link to this example. So here's an example. You have a car or bicycle, both are kind of vehicles. They have different fields, but the type is either car or bicycle, and you want to deserialize it. You can use variant, but nlhomann JSON doesn't work with stud variant out of the box. You need to help it. You need to help it by reading the type, creating the actual instance, and pushing it into variant. So that's the trick that we'll take a look at. So I'm going to show you the code where you actually inspect. You'll be able to inspect the type. By inspecting the type, you can create the instance and then push it into a variant. Okay, and it's gonna look very clean. The secret here is this ADL serializer, which I wasn't aware of. This is basically the secret sauce. So let's take a look at this nice solution that Jacob is providing. This works well. I have a compiler explorer. So car has license plate, bicycle has just a Boolean, bell has bell, true or false. From JSON, once I have a JSON structure, I can get a car or a bicycle. It's a kind of overloaded function and populate it with whatever I have from the JSON. So I'm using, not me, Jacob is using strong type enum, and this is something that nlhomann JSON serialize provides. So think about the vehicle type, which is in enum, and then vehicle type car is car. This is the identifier, and then bicycle. And then we have a variant. We basically going to push that to a variant. This ADL serializer is doing everything for us once we have. So we as users of nlhomann JSON would define this specialization of a template struct inside the namespace of nlhomann, so it can be found from JSON. To have JSON as J that was written, we want to deserialize it to the structure. So vehicle is the variant type. So by having this J at type, or get the vehicle type, we'll get the type here, and we can. This is the enum, and we can now do a switch case, right? And getting a car or a bicycle, we can get back either car type instance or a bicycle, and v, which is the output, its output variable, would be populated. So when we parse the JSON and we have this function defined, we would get, as we go record by record, we'll get the vehicle, the correct vehicle parsed, which is with the correct fields. We only have 2 here, but you can imagine much more complicated structs. And I do have, see, I do have an example. Okay. And I thought this is super interesting solution. Okay, let me just make it a bigger. Let's see. Okay, hopefully this is easier. So this is what I showed you in the slides. And what we do here, this is this ADL serializer under nlhomann namespace that we need to define. And let's say we have this, we're using string here, string literal. But think about a file that we parse, and we have this is a circular rectangle. It's not a vehicle, but it's the same. This is from the blog post. I have a different example in my slides, and this is being parsed, and then we can have the shapes.size. So we have 2 shapes. You can see it here, and then using the nlhomann JSON shapes, we can dump, and this is just the indentation, and we can see that it's being parsed. So this shape is basically a variant, and we're creating them when nlhomann JSON is parsing that, this function would kick in, and for each record, it's going to create one, return the vector of shape, which is the variant, and we can dump that into screen. I think this is really, really cool. I wasn't aware of that. This is where you define each of them, by the way. So this is the enum to string. So basically these guys, and then the actual members of each of them. Very interesting solution. I wasn't aware. If I knew about it, it would definitely save me a lot of manual parsing, because we usually do it in a manual fashion. Who is using this library to parse JSON and do any JSON from C++? Anyone? Because this is very, very famous. I think this is.
Is this library latest one, or is it it exists for quite some time?
Oh, it exists for many years. I don't remember. This one has a 46,000 stars. Someone says it's very popular. Let me see. But just not using JSON. But it's very popular. Like, a lot of people familiar with this library. I'm using it for, I would say, at least 5-6 years, at least. But if you look at the activities, it has almost 5,000. I don't know if I'd be able to even go back to the beginning of time. But this is very old and established. There's also SIMD. That I also used. So SIMD JSON. This is Daniel that we just showed his blog post. So he is the author and the maintainer. So very interesting person to follow, by the way.
So just quick question. So do you mind explaining the toJSON function? Maybe I'm not too familiar with that syntax.
Okay, let me see. So
So
I'm actually realized that I'm presenting something that you don't see. So I'll explain. So this is what I actually was browsing that I realized that I'm not sharing. So this is the SIMD JSON. This is Daniel. And nlhomann JSON. Sorry, I'm looking at my tab and I'm not looking. So this is the nlhomann JSON. It's 46, more than 46,000 stars. So it's MIT license, so it's easy for everyone to take a look. Okay, let me go back. Okay, so which one?
toJSON. So you're taking the shape and trying to convert it to JSON, right? So
Okay,
from 57 to 63.
This one.
Yeah.
Yeah. So this is basically the reverse. This is not this order. This is I have a shape, and if this holds alternative. Are you familiar with stud variant? This is a from JSON. So I have a JSON object, right? And I want to start deserialize it to specific C++ class types or struct.
Yeah. From JSON is pretty looks reasonably understandable, but toJSON, it's called hold alternative and get. What is the get?
Hold alternatives is just a function that the shape is a variant. That's why I'm asking if you're familiar with variant. There are multiple ways. Let me show you something.
Yeah, even if I can understand that holds variant, but
so
get
stud variant would have so hold alternative is one way to ask, is this type in the variant or that type of the variant? There are other ways to do that. Visit is kind of a more kind of a much more advanced way to do that. But there is get, and get will throw an error. There is exception, but bad variant access, just like you have stud any, you try to cast stud any to something. So basically that's, someone said something, let me see. Yeah, visit is more idiomatic, big fan of visit. So, okay, so this is just a utility function to ask, is this a circle, true or false? If it's a circle, then get a circle from the shape. Stud get basically is a template function to kind of retrieve that, and then J has a assignment operator.
So that get function is implemented somewhere for those classes.
Yeah, stud get is something from the standard library.
So how does it return the JSON?
This one is not returning a JSON. A stud get.
But it is assigning to J, right? J
Yeah,
is
so there is an operator, an assignment operator that is defined, could be a template that is implementing this assignment operator. Like that, without looking at the code of JSON, this is the only, because stud get, if you look at stud get, show you. Stud get, defining variant, it returns a type that is one of the variant types that the variant is actually holding, one of them, okay? So if you have a variant of int and float, stud get of a specific, there are all kinds of ways to do get. Because there is a way to do it by, I think, index, if I'm not mistaken. Let me see. But anyway, I don't know if it shows. Oh yeah, here it is. So this is 0, and this is 1 in the index of the types in the variant. And when you have stud get of int at v, if you do this, it's gonna have an error. There is no double in the variant. So you're returning the actual integer representation of this variant. That's it. That's the whole. That's the whole.
Yeah.
And if you do something bad, it would throw an exception. If you think about like a union, if it holds an int and you try to get a float, you'll get bad variant access.
I understand. So my question is that in that particular instance, like it is asking for JSON object, right? So how is it getting the JSON object? So it is taking that circle or rectangle object and creating a text for a JSON format, right? So how is it doing that conversion?
That, without looking at the code, the JSON code, because this is J equal some type, right? So if you look at the function, this JSON would have an assignment operator to some type, and it needs to do something with it. So
you mean to say that there is a equal to operator overloaded? How does it? So in that line 60, what happens to return a JSON object, right?
yeah,
An operator overloaded a function that is somewhere implemented in the JSON library that is actually taking care of it. So something has to happen to.
Yeah, and without looking at the JSON, nlhomann JSON code, there might be this macros might add code that helps this conversion. For example, these ones. Sorry, these ones. So by having circle, it knows that, okay, these are the fields, and it creates a JSON. It's serialized it to JSON with these fields, and you need to look at the code in order to understand how nodes of the JSON would look like. It might be stud any.
Yeah, yeah.
It might be all like without looking at the code, but this is without doubt. This is a JSON equal a specific type. JSON. This is probably a class.
So in this case, the L value, R value has to same, right? So basically, the R value has to be some JSON object. So who is generating that R value is my question. So is there some kind of operator load function in the JSON library that is doing that, or some?
I think this if we dig into the source, if we put breakpoints, we'll see an operator equal that is doing all the heavy lifting. There is no other way.
Yeah. Okay. So it is part of the library, JSON library.
Has to be part of the library, yes. And I have a feeling that these, without expanding these macros, I think this would do the trick. Okay, we actually have 5 minutes, which enough for one more topic, which is what I'm going to show next. Something that I bumped into some time back, and I thought this is going to be very interesting to present. It's not C++, it's C, but it's kind of a C++. It's kind of a C quiz. Take a look at this. And tell me, this is taken from Twitter, like X. Tell me what you think about that. What would be the printfs? Like what would first, 1.5, and second would be? Okay, so I'll explain. There is a struct with 2 members. First, 32-bit, and second, 64 bits. So this is the struct, and this is C. And we have a main. You can see that because it's type def and main void and all of that stuff. So we have first initialized with 69, second 64 aligns on 8-byte address. There is already a huge hint here. This is correct. So 69, 420, and then we have this funky expression. We take the address of first, then 1, step 1, 104. What happens here? What do you think is like, what is first, what is 1.5, and what is second?
So basically, it is setting the second to 104.
Second what?
So I don't see the line numbers. Otherwise, I cannot tell you. So basically, in there is 104 is being set to first of array of 1, right? So it is typecasting the entire structure to integer arrays and then setting it to 104.
Yeah. So we take a look at A, B, or C, or D. Which one is going to be printed?
Yeah.
C. C is correct. So let's see what happens here. So this is all about padding, and it's a very straightforward, and I'll explain that. Let me jump to this slide, because this slide is actually the interesting slide. So this struct has 32-bit, which is 4 bytes, and then 64-bit, which is 8 bytes. So the second one is aligned to 64, which would mean that there's going to be some padding reorder variables. Come again? What reorder variables?
I'm just saying, if we want to get rid of the padding, can't we reorder the?
Oh yeah. So the padding would well, you'll have different padding, because it's going to be the size of would be by the biggest
member.
The biggest number. And the idea is when you put it in array, there's going to be a line. And someone said pragma pack is going to fix that, and this is true.
I think Jakob. So I think that is maybe it may not be right. So it is based on the processor architecture. So in this case, if you make it as a 32-bit, if you run this one on a 32-bit architecture, it is all word is correctly
yeah,
aligned by 4 bytes.
I
So,
agree. It's
so
split.
here, if it is x86, that means that's why it is 8-byte aligned.
Yeah.
Because the memory fetch is going to happen in one memory cycle.
Yeah,
So
yeah.
this is because
I
of the
agree.
fetch, not because of the.
Yeah, I agree. I apologize. I should have said that. I did not on the architecture. But okay, so just imagine it's 64. So the padding is happening here, and this is basically when we do pointer arithmetic with D first. D first is a 32-bit, and +1 is basically just jumping one. And what people say, this is a way to hide information. Sometimes you do it in padding. But what I wanted to, before we go and finish the session, I just wanted to talk about zero initialization and padding. Long story short, when you what is the value of padding when you do zero initialization? Anyone aware of? So I actually was interested to know, and I looked in the standard, and it seems like zero initialization is guaranteed to have everything, including padding, initialized to 0, not value initialized. Value initialized is not the case. I just have another example here to show, but value initialized is the standard doesn't say anything about that. So this is 0 initialization. Static T object is also 0 initialized. So the standard does say that this is going to be initialized, but not value initialized. The standard doesn't say anything about the padding. So you can't really do mem compare if it's value initialized. This is something that you need to remember. In C, it's much easier. This stuff are much easier, but in C++, it's there's some trick stuff to do. That's it for today. People need to leave anyway, and I mentioned that I have a hard stop at 6 p.m. I'll continue what I had. I had a couple more topics, but we'll do it next time. That's it for today. Thanks everyone for showing up. Hopefully you learned new things today. See you next time.
Do you have any YouTube channel?
Yeah, we do. San Diego C++ Meetup YouTube channel. If you just Google that, you'll see that. And just ping me over LinkedIn or Meetup page if you have any question about links and anything that I can help with. Okay.
Hey, Kobe, quick question before you go. I was wondering, I saw your post about the your review of the memory management book, I believe it was, and I was wondering what device were you using there to read it?
Oh, this is a Remarkable Paper Pro. It's a e-ink device. It's kind of a niche device, but I really love this device. It's just so fun to use it. Like the feel, the paper-like feel on the device. This is a colored device, so they had this is something that was published, like it's a new product, I think, from end of the last year. Before that, they had the Remarkable 2, which was black and white. Like you can do colors, but it's only when you export that you'll see the colors, not on the device itself. And the Remarkable Paper Pro has brightness control, which you can actually. This is nice if you are in a dark room, which they didn't have this feature. It's Linux based, so if you go online and look for all kinds of hacks, people have all kinds of GitHub projects that you can improve the features of your Remarkable Paper Pro. Not that I'm endorsing any of this, because I don't know, I'm not using this yet. I'm not just keeping it vanilla, but it's all Linux based, so you can actually SSH to the device and things like that.
Well, do you recommend it for like technical books, or is it?
I like it for technical books, like reading, and I like writing notes, and it just kind of I'm addictive to, like, it's really fun. So
All right, I'll take your word for it.
yeah. By the way, they have an amazing policy. you can use it 100 day up to 100 days and return it, no question asked, will get your money back, which is amazing. Like
Yeah.
if you look at the Reddit, some people like say, okay, I want my iPad back. I don't want that because it's expensive. It's expensive
is.
device. So, but 100 days,
All
no
right.
question
Okay.
asked.
Can't beat that.
Can be that, yeah.
All right. Thank you.
Thanks, everyone. Have a good day. Take care.
Thank you.